I would, as Indranil mentioned, I represent the Swiss Agency for Development and Cooperation. We are a bilateral agency working as a partner with Government of India for a very long period of time. I just hope the slides come so that I could show you. Today I would essentially try and present our experience of working in India of over last 2 decades on bridging the energy access gap. We started working on energy way back in 1994 with a focus on trying to diffuse or introduce clean energy technology solutions both through the measures of energy efficiency as well as through renewable energy access in the different sectors or different stakeholders. So that's basically what I would like to share, our experience, our journey, and the story around our lessons so far. Okay. So SDC has been a technical partner for over 50 years in India. Our development cooperation program has evolved over a period of time as the development priorities of India have evolved. So since 2011, our program focuses specifically on climate change. That's the agreement we had with Government of India that this is where we would essentially engage. And essentially, we are part of SDC's global program on climate change. So that's the one of the key global cooperation initiatives of the Swiss Agency for Development and Cooperation. Our goal in India is basically that we are partnering for climate compatible development, and we basically engage that through actions on both the field of climate change adaptation, which is working with communities, working with stakeholders to help resilience to climate change impacts, and also working with different stakeholders to mitigate risk of climate change essentially through the reduction of the greenhouse gases. So that's the balanced domain of both mitigation as well as adaptation. So these are the two theme areas that we essentially engage. And these are the sub-sectors within each of this domain that we basically focus. So I won't talk about adaptation because that's not a topic here, but on the, if you see the lower part of the slide, which is where we focus on mitigation, we deal with renewable energy, which is essentially looking at access to clean energy. We work on built environment. There are a lot of initiatives which is focusing on energy efficiency across buildings, new initiatives around cities, construction materials, energy efficient construction materials, or this one, and as well as engaging with the small scale industries, both for energy efficiency as well as for clean energy diffusion. So what I will share today is our experience around renewable energy as well as engaging with small scale industries, which is kind of linked as an overall program part of it. In 1994, when we started engaging in the small scale industries, one of the things that we identified was a set of industries which are very energy inefficient in terms of very high energy use, and these were typically brick, glass, and foundry sectors spread over the country, which is very large energy intensive process, and high dependence on fossil fuel. But as part of that analysis, what also came out was there's a small scale industries in India use a lot of energy and the processes are very inefficient, and the energy mix varies from location to location. It's in form of fossil fuel in few places, it is form of biomass fuel, it is also in form of inefficient fuels locally which is available. So for example, in large parts of southern India where waste rubber is available, that becomes a fuel for food processing industries because it's cheaply available, low cost, and therefore gets easily absorbed. So what we started to work was to look at biomass gasifiers as a technology interventions, as a clean energy technology, to look at the process around the small scale industry. That was the beginning. Now, gasifier is not a new technology. It's been used worldwide all over the places. You can even find pictures of the Second World War period where the gasifiers were being used even to power a car and run in some of the European countries. In India also it was basically being used. Where we worked essentially in our partnership with TERI was to look at the end-use systems, integration of the system with the gasifier for different applications. So one of the early starts that we did was in the sericulture industry, where you need to basically just boil the water, but various forms of inefficient processes were being used, and that we basically transferred through the gasifier into a more efficient process of heating water. And from that experience, over this 2 decades, our journey, we have essentially evolved the technology, the entire system, which is essentially joins with the gasifier, the biomass gasifier, and also entered into sectors which were never initially open to technology as a gasifier. So as late as recently, we have started working with the ceramic industries, which basically has a very high end-use temperature range of over 1200 degrees centigrade, but gasifier essentially has now reached that level of efficiency that it can actually meet the energy requirements or the temperature requirements of the industries. Towards 2000, we also decided that we would add to look at the rural electrification aspect, because that was one of the key areas that we started to focus. And a couple of slides I'll show what we have done in terms of the innovation on the gasifier for enhancing access to electricity in regions which are surplus with biomass. So basically, as we said, there are low capacity end users. Basically what we mean by low capacity end user is that those who have no access to energy, or if they have access to energy, then they do not have a reliable and a consistent supply of energy. So that means we basically focus on households as well as on small scale industries. Our approach was that which kind of a model we should basically follow. So there are a lot of initiatives around the bilateral cooperation which looks at financing schemes, which looks at to promote adoption of clean technologies. These are mainly line of credit which is available for diffusion of clean technologies. The second is more on towards the demonstration and dissemination of clean technologies, and the other is initiatives which focus largely on policy or regulatory interventions, and kind of capacity building which is cross-cutting across these 3 sectors. SDC's focus was on demonstration and dissemination of clean technologies together with capacity building. So that's largely has been our entry point in the MSME sector, also in our work towards the households electrification program. Now this is one of the important clusters of the low capacity that we deal with. There are roughly about 36.2 million enterprises in the MSME sector spread all over 180 clusters in India. A major contributor to economy in terms of GDP as well as in terms of manufacturing outputs and the contribution. But the last point, which is in terms of the employment, this is second after to agriculture. So there's a lot of focus essentially also going on in terms of establishing industries, in terms of micro and small medium enterprises. But at the same time, what we've realized is that the energy requirement in these operations is very intensive. So therefore, roughly around of the total commercial energy use within an MSME is around 50%. The costs vary from anywhere 30 to 50% of the total production cost. So that means there is a lot of opportunity to intervene in essentially making the processes more energy efficient, and that can happen either through efficiency route, which we deal in some set of projects, but we also deal it in terms of the technology dissemination. Over the last 7-8 years, what has happened as a result of once the product reached a commercial stage, we have seen over 800 replications. Now, in a country of size of India, 800 replications is a very tiny number, but that's the challenge that we face in terms of replication. It's in terms of creating awareness, in terms of creating a niche for the technology for certain applications. But one thing it's very clear that in sectors where this technology is essentially moved, it has actually shown that it is a cost-effective alternative. And it also has resulted in many sectors a positive spin-off. The third basic impact has created is that it helps in local manufacturing. So you don't have one large suppliers and therefore supplying in clusters where you find potential. What project essentially has been trying to do in terms of capacity building is to identify a local manufacturer who can assemble the systems locally. But our lessons shows that there is a very large untapped potential which is still to be captured, and projects of these nature needs to evolve constantly over a period of time to address to the requirement. We feel that in terms of technical capability and application, gasifiers can meet thermal energy requirements of a very small range from 25 kilowatt thermal to as much as high as 3 megawatt thermal. So that is the scale at which essentially it can vary. From as low as 80 degrees or 60 degrees temperature, which is typically for boiling application or heat applications, to about 1000 degrees centigrade and even higher now, as we've learned from our experience with the ceramic industry. And there are large potentials which we have sectors where we already made some entry, but again there are so many such clusters spread over the country that if you make entry into one cluster in one area, there is a lot of opportunity that it can be replicated across different clusters. It's also very economically attractive for gasifiers. We have seen, we have documented evidence in terms of how the payback periods have really worked. So in case of fossil fuel, it has varied anywhere, wherever replacement has happened through a gasifier, from 6 to 9 months. And in where the traditional fuel or the process was already using biomass, we've seen that period is longer in terms of 18 to 24 months. The other benefits are quite evident in terms of the cost benefits reduction in terms of the productivity. But what we've also seen is the improvement of the quality of product. Because we are in a position to better control the temperature through a thermostat, and also with now more industries demanding automated system altogether of a gasifier, there is an improvement in the quality of product. And that is giving more impetus for industries essentially to shift. Especially in the food processing industry, it's quite an important factor to have a constant heat temperature. But what is acting as a driver also now is a growing enforcement of environmental regulation from the state pollution control boards, which is asking essentially small scale industries to become much more cleaner in terms of the production facilities that they have, and enforcement of those regulations is happening, which is acting as a driver for clean technology essentially to move. But as I said, there is a continuous challenge. Gasifier is not a product which is on a shelf or in a market which is available and you can go and install it anywhere. It has to be customized for every single application that is there, and that acts as a challenge. Even though we know that there is a huge potential, it requires time in terms of creating awareness, in terms of tailor-making the systems, and on a constant basis. Although in clusters where the project managed to make an entry, there have been local manufacturing capacities have been built, but it requires a constant upgradation of the system based on the experience with the MSME industries in terms of the backup maintenance services, in terms of skilled services which is essentially available. The biggest challenge a project like or a technology like gasifier faces is the supply of biomass. Although we have looked into the entire supply chain and the sustainability of the biomass supply chain, what really goes into gasifier is not the first level of primary biomass. It is basically tertiary or the third, fourth application of biomass or recycled biomass basically which is being used. But then it's still a question in terms of the biomass sustainability or what is the source remains a challenge and creates a barrier in terms of diffusion of the technology. And then even if we have made some successes in certain clusters where we have almost reached towards saturation, but there are still information gap, there's still knowledge gap which exists in terms of which acts as a barrier. And because this has always been a funded project through a bilateral cooperation, the scope of technology innovation has been very limited. And whereas in the private sector, in the commercial sector, there's been much better and faster generation technologies now available, the gasifier that we deal with, it still has a lot of problems in terms of, when you install it, it looks like a very basic root technology. And in certain applications like food processing, if you see the picture, this is from a food processing unit. Any inspector who comes for inspecting a food processing center, when he sees a gasifier like this, they don't like it. So that's a challenge which is there. The technology, in a way, upgradation constantly to make it much more suitable with the requirements of the changes in the industries is also a challenge. The second set of low capacity end users that we have been working with is essentially the households, rural households for electrification. These are some numbers which constantly keep changing, but more recent data essentially shows that even at present there are 10,500 villages which are unelectrified, spread over 19 states. And there are about 54, 55 million households which still do not have electricity. And those who have, from our experience that we have seen where the pilots are coming up from our project, even if they have electricity, there are problems of unreliable electricity supply. So what have we basically done in terms of household electrification? So there is, again, a technology which was the gasifier, power gasifier technology that Terry basically had, and that was their core competence for many years. But there were several problems with this particular gasifier. From an environment point of view, it generated a lot of tar in the combustion process of biomass. You therefore needed to clean that tar, and that generated wastewater. Disposal of the tar was a problem, disposal of that wastewater was a problem. The consumption of biomass was also much, much higher, although technically it was always said that it's anywhere varying between 1.5 kg to 2 kg, it was even higher than that. So there was applications of these gasifiers were already happening in this country, and there were several projects of this nature. Even one of the projects that we helped was also in partnership with NTPC, was because they had put up similar projects of this nature spread over their field locations. So what we essentially did through our project about 7-8 years back was that we looked at a more advanced gasifier which was available with Danish Technical University. Now, this was also unusual because as a Swiss agency, we typically look at technologies or choices which are available within the Swiss universities or Swiss lab. But in this case, as a gasifier technology, the best available technology or the most efficient technology was in Denmark. But SDC has always maintained that if we do not have the most effective technology even within our own boundaries, then let's look at technologies elsewhere. And that's how we went basically to map the Viking gasifier which the Danish Technical University have. And what we supported was bringing together of these two technologies and therefore then create what we call now as what is called as a two-stage biomass gasifier. Now, the prototype was developed. So this is an amalgamation of these two different technologies. The Viking gasifier, it works with a very different type of biomass fuel which is not available in India. The fuel quality is much different here. Therefore, it had to be adapted into this context. So this is what the project, this gasifier, it's an adapted technology by modification of the Terry's own gasifier, and it takes the better features of the Viking gasifiers and make it into a two-stage. This has essentially addressed some of the problems that was there with the traditional system. We don't have a problem of tar, because the tar, it goes to a higher temperature, it gets cracked. It comes in form of a powder, therefore it can be reused mixed with another forms of biomass as a charcoal. We don't have any, therefore, since there is no tar, we don't need water to cool as well as for cleaning, and therefore there is no requirement of water. So it functions more like a simple power gasifier now in a technology which is much more efficient in terms of this one. And the use of biomass has come down quite significantly. So it's about 1 kg per hour per unit is basically what we basically need now. Now what we are doing essentially with gasifier, so we spent about period between 2006-07 to 2012 in terms of testing the prototype at the facility that Terry basically had. With a smaller capacity 10 kilowatt system to look at how it can actually be adapted, what are the changes to be made, etc. Once we reached that scale that it was possible that yes, the system works, we have essentially gone for a more larger scale system. We have now already installed the pilots in 2 locations, 2 more will come. In fact, today, as we speak, one of the plant is getting commissioned in Western Odisha. And what we are also doing is making it much more low cost in nature. Several of the costs of components which is there in the Viking gasifier has been adapted by working with the local technology suppliers here in India, which makes the cost even much more affordable for installations. So they are basically working on 2 sides. One, we are putting up pilot projects. We'll put 4 of these pilots on ground. The picture you see on the extreme left, that's project in Raigada, again in Western Odisha. It's already commissioned about a year back. It works with a women self-help group in terms of supporting their micro-enterprise, and I'll come to the second part of what it essentially is doing now. And the second one, as I said, is the one which is getting commissioned today in Koraput, again in Western Odisha. We are also testing it for a different type of fuel, so bamboo as a fuel, because we face constantly this question about where is this supply of biomass essentially coming. And so there is a pilot which will get commissioned middle of next month in Madhya Pradesh in a bamboo facilitation center. So waste bamboo from that processing unit will become this fuel source. And the fourth pilot is coming up again in Odisha, but it's in an unelectrified village. So it's the 4 different pilots. The second part that we are basically doing, and that's where the most interesting aspect of the new aspect of the project essentially is, we are working with the developer to make this gasifier which we have installed in Raigada. This is in a grid connected area, so there is electricity was always there, but electricity was not available most of the daytime for the enterprise to run, and the evening for households to have lighting requirement. The pictures that you see on the right is a signing of an agreement between the developer, which is responsible for generating electricity in the Raigada project, with the local utility, which is Southco of Odisha, Southern Distribution Utility of Odisha, and Gridco, which is the grid company of Odisha. As the person who is sitting on the chair behind and for the remark that this is the first time they have signed an agreement of a power purchase agreement for a 30 kilowatt system in a grid connected area and managed by a women self-help group. So these are this one. So what we are actually doing is, we are waiting now for an order from the Odisha Electricity Regulatory Commission for a tariff at which the grid will buy power, the surplus power in the evening, and these villages will get electricity from this gasifier in the evening. So the daytime will be used by the women enterprise to run the micro enterprise that they're running, and the evening the surplus power essentially would get. Once this happens, this would probably be one of the early projects which actually would integrate a decentralized renewable energy with grid. We have several examples of off-grid projects where renewable energy is playing because developers are setting up parallel distribution network for providing electricity supply. But to feed it into grid at a transformer level, this would be one of the first projects probably. So that's our experience so far. We can basically say development and diffusion of technologies, especially when we work with sectors which are not so much in priority at times, especially the micro, small, medium enterprise, it takes time. It continues to take a lot of effort in terms of the resources that you need to put in. And we, again, constantly need to keep on improving the efficiency. Otherwise, the systems become redundant beyond a period of time, as well as the effectiveness in terms of the dissemination. If we want to scale up gasifiers for thermal and heat energy applications in the small-scale industries, MNRE actually has a program, but it is fairly not as prominent as it used to be. Solar has taken over most of the other renewable energy systems now. There is a need for a more holistic energy policy, because what MNRE does and what the Ministry of Small and Medium Enterprises, there are mismatch between the two right now. And therefore, unless that is not brought together, we can't really see the upskilling essentially to happen. And of course, for that, there will be a need for a different set of stakeholders to become effective in terms of the kind of after-sales service that you require, in terms of skills that is required to provide services at the field level. Our belief is, and it gets strengthened from what we have done in Odisha now, in terms of renewable energy for electricity access. In the current scheme of things, decentralized renewable energy is slowly going to disappear if the business as usual essentially continues. Slowly grid would reach most of the villages, except for few off-grid areas, few islands, few remote locations, few forest villages where grid may not reach for different reasons. In rest of the places, grid would reach. But reaching grid does not solve electricity access problem. And therefore, if decentralized renewable energy needs to remain viable, it needs to find a way to find itself to connect to the existing grid. And not be scared of the grid coming and saying that we become unviable. That's the challenge in the off-grid areas when grid is coming, developers are essentially facing. And we hope that the experience that we have had in Odisha, which has actually last week, and I also saw the Rockefeller Foundation being involved in this, got them excited because they have a 1,000 villages, 1,000 villages program. And that has basically got them excited. And if this kind of a regulation comes through in Odisha, it will help them to move projects in Bihar and UP where there are large number of unelectrified villages to be there. So that's our experience so far in terms of and how we see moving forward, especially with the experience that we have so far. So we've done some initial work of looking at inefficient sectors, especially the MSME. SDC was one of the early ones to work. We've tried to bring some cleaner processes in place. We've changed technologies, we've changed processes, but a lot still needs to be done, and it's not yet over. I mean, and I think for us, as we start to look at the 2 decades of experience with the biomass energy, we still know that a long way still has to go as far as if we want to change the processes within certain critical sectors. So with this, thank you very much for your kind attention, and if you need this one, you can, let's move to that. Please.
These biomass converters, what do you mean by efficiency of a biomass converter?
We mean efficiency in terms of the fuel use.
Fuel use.
Yeah. So what was the fuel? So these are monitored, these are measured in terms of what was the previously the consumption.
Okay. The second point is how you ensure a continuous supply of raw material of right quality specifications at any biogas plant.
Okay, in the biomass plant.
Biomass plant.
Okay.
That is a big problem in my opinion.
Yeah. I agree with you. That's a major challenge. What has happened in that in
because
all...
in India, most of the biomass is committed for use.
Exactly.
Whether it's a grass or wood or leaves, everything.
The biomass finds a major application and it's a dedicated sector, it's a viable sector. The local service provider who also provides the technology...
You have to involve community.
No, actually, most of these are in the industrial areas. So there is a local service provider who is basically a skilled, basically the technology provider. They also provide biomass supply. So they also act as a supplier for biomass.
The whole supply chain has to be developed, otherwise they fail.
So they are part of the biomass supply network.
Even a 10 kilowatt biomass gasifier won't work.
Yeah. So that supply chain has been looked into, and they have a clear supply chain which is available. So they not only provide technology and backup services, they also provide biomass on a regular basis.
You have to break it, you have to maintain its
it's
moisture.
done. It's done in that form.
It's by itself a technology to to make the input biomass for a biomass gasifier.
So there are both. We use woody biomass. So for example, in Bangalore, there is a recycled packaging materials which is used by the industry. So that comes as a waste, industrial waste. That is processed, put into smaller pieces, and then supplied.
Have you tried any catalytic biomass gasification?
No, we have not.
Not yet, because that avoids the tar problem.
Yes. Yeah.
This is related to for your project in Odisha. You said you had a women's self-help group look after and run the whole thing. How did you manage to get them to do O&M? I presume they weren't really trained engineers.
So they have been trained by the partner, Terry. They have been trained. There are in the Raigada project there are 5 trained staff. See, they were already running a micro enterprise which was diesel based. So they had 2 people who were running the different machineries. So those 2 plus 3 other people were basically trained. So they run the gasifier now on their own. There is no longer, there was a period of 6 months of handholding support provided once the gasifier is installed, but now it's completely managed by on their own.
They've had no problem with supply chain management or maintenance?
This gasifier requires very little maintenance if it is managed and run properly compared to the previous one. So,
thank you.
Just a quick, sorry. What could be the price if we scale it up at certain extent? Price of per kilowatt hour generated? Do we?
Cost is kind of covered, either through the project or through some other, for example, the one which will come in the unelectrified village, the rural electrification, it's part of the rural electrification corporation scheme, so capital cost is covered. So typically, in this case, especially the one in Raigada where we have the tariff order has been filed, I think it is ₹3.52 per unit. But this is after subsidy on the capital cost. If that's zero capital cost been taken. If you take it into account, all the costs not covered by the project, this would be much higher, around 9 to 11 rupees per unit. So nowhere competitive with what solar has reached now.
Sir, hi, I'm Sandeep. I'm from a company called Feedback Infra. In fact, we have a distribution franchisee based out of Orissa called Fedco. And in fact, I mean, this is a very interesting way. I mean, we also have a self-help group called Sefali, which manages the MBC primarily in that area. Just wanted to ask you a question. I mean, in terms of the business model, do you have a escalation sort of a matrix in terms of the power consumption increase year on year in these villages, and do you have a proper analysis?
There has been an analysis which was done in terms of deciding the load as well. So before deciding the boundary of which the project will connect to the households, complete load assessment study was done, and therefore.
What's the base load here?
The base load is the enterprise. They need about 20, anywhere between, depending upon the machines that they operate, between 12 to 18 kilowatt loads.
Okay. I mean, primarily, if I'm not wrong, I mean, you probably need some sort of a commercial establishment, either a bus stop or maybe something like a telecom tower, to be precise.
Yeah. So
is
that's
that the case here?
So that's the micro enterprises women self-help group. That's the base load.
Okay.
Yeah. So that is the load, and in the agreement that has been signed with this one, this will operate from 9 in the morning till 4.
Yep.
And then from 6 in the morning till 9, the supply will be to grid, and from 5 in the evening to 11, again it will be to grid. And this being a renewable power, this has a right of first supply.
First supply. Okay.
So this gives the gasifier to have a continuous viability.
Thank you.